Hello and welcome to Dove Biology APES Lessons to Go. In this video we'll be exploring an introduction to food security and soil. Food security means that every person in a given area has daily access to enough nutritious food to have an active and healthy life. In terms of nutrition, that means that that food has sufficient macronutrients and micronutrients. The major macronutrients that food needs to have would be proteins, carbohydrates, and fats, while the micronutrients are the many vitamins like A, C, and E that we need for our health. Now, with the help of technology and improved farming techniques, we have managed to maintain our global food production well ahead of population growth. So that means there's more than enough food for every person on planet Earth currently. So why is it that people are still starving? Well, unfortunately, that food can only be produced in certain parts of the world. Certain areas are more suitable for growing food, and then those many people don't live in those areas. So getting that food to those people is a difficult task. One of the primary ways that we make our food or get our food is through agriculture. Of the 57 billion acres of land on Earth, only 7.68 billion acres is considered arable. And that means that it has soil that is suitable enough for growing crops. Now, to add insult to injury, each year the amount of arable land is lost at a rate of about 38,000 square miles per year. Now, this is the result of development. So when we build homes and shopping malls on top of farms, we're not going to have access to that great soil. Poor farming techniques, and just simple soil erosion. When it rains on soil that's not protected with plant cover, it's going to just roll off the land and be lost forever. So if we can understand the nature of soil and how to conserve it, it means that we're going to build a much more sustainable future. Now, soil is actually made up of four major components. Soil is mostly water, air, organic material, and then the breakdown of the parent material that made that soil. The particles of soil itself is going to be a homogeneous mixture of sand, silt, clay, and organics. The composition of these particles is going to help determine its overall texture and its suitability for growing crops. Of these particles, gravel and sand are going to be the larger particles, while silt and then clay will be the small particles. Although soil is a potentially renewable resource, it's produced very slowly, about 1 inch every 500 years. There are three major processes in which soil is produced: weathering, deposition, and decomposition. Weathering is going to be our primary way that we're going to get some soil, and that is the physical and chemical processes that are going to break down that parent material, chemically altering it and producing those smaller soil particles. The next process will be deposition, and deposition is where weathering has happened someplace else, producing soil, and then it gets moved by gravity, wind, or water to another area to build up soil in that region. There are two basic types of deposition. It's alluvial and colluvial. Alluvial deposition is when the sediments are deposited by water, and that usually happens in floodplains. When streams and rivers, when they flood, that water pushes sediments that have been moved through that moving river up off the banks into those floodplains. Colluvial is when the sediments are deposited from a slope, typically from gravity, maybe wind, maybe a little bit of water. And so at the bottom of mountains or major hills, that's where we're going to see a lot of colluvial sediments. The last thing that is going to really help to add to soil formation is going to be decomposition. When animal and plant material decompose on the surface, those organics get added into the top layer of the soil, enriching it and giving it the nutrients which is going to help support plant growth. So, our formation of soil is going to look a lot like the whole idea of succession. And in fact, succession and soil formation are oftentimes linked. With our soil formation, we're going to start with some sort of parent material. And whatever parent material we start with is going to kind of define our future soil. Initially, that parent material needs to weather, and so we'll have physical and chemical weathering from the elements. Rain that's slightly acidic, moving wind, it's going to begin to break down that parent material. That's going to allow then for our pioneer species, our early species like lichen and mosses, to begin to establish themselves and further the weathering and the chemical breakdown of that parent material. Now, as they pass away, their organics are going to be added into the top layer as well. And so we're going to start to form layers of soil, which we call horizons. As we allow for the establishment of plants that then can have roots, the roots will go down and expand and get into the cracks of the parent material and help to break it apart. And so over time, we're going to see the development of specific soil horizons. So there are 5 factors that are really going to impact soil formation. We actually can remember them using the acronym CLORPT, C-L-O-R-P-T. So the first factor is going to be climate, which is where we get our Cl. See, temperature speeds up or slows down the chemical reactions that are going to break down and weather the rocks and minerals. If you have areas where there's a lot of rainfall, then more water is going to drain down, leaching the minerals through the soil layers. So it's going to affect that soil formation. Our O is for organisms. Burrowing animals like worms, pill bugs, growing plant roots, enzymes secreting bacteria and fungus are going to chemically alter and mix that soil. Now, R stands for relief, and that's really talking about the topography or the slope and direction of the land. This is going to influence how much sunlight a particular plot of land is going to have, the temperature of that area, the speed of the water that's running off the surface that's going to help with that physical weathering and erosion, or even to allow the organic buildup. If you have an extreme slope, it's not likely that a lot of organics are going to build up on that extreme slope. Our P is for our parent material. Remember I said that whatever parent material we have, it's really going to define our soil of the future, because it's the chemical composition of that original unweathered rock that will influence the mineral content of the soil. Parent materials can be the underlying bedrock, but most are the sediments, the sand, the silt, the clay that will be deposited from someplace else. And lastly but not leastly, we have T for time. Remember, 1 inch equals 500 years. The speed of that really depends upon how long we have and what kind of material is present there. Older soils are going to be broken down more weathered than a younger soil. Soils in the tropics tend to be old because they haven't been affected by the remixing of our periodic glaciation. Now, as soil forms, it forms in distinctive layers, which we call horizons. These layers differ in chemical composition, physical properties, particle size, and the amount of organic material. In general, the layers in the uppermost portions are going to contain more nutrients than those in the deeper layers. Now, in certain environments, we're going to have a significant amount of organic material on the surface. This layer is going to be referred to as the O horizon. This O horizon isn't really soil yet. It's like pre-soil. It's the organic material that sits on top of our real soil. This is going to consist of our decayed plant and animal material that we call duff. Now, a forest will have a deep layer of these organics because there's lots of plant and animals then to be added to the surface, whereas a desert won't have any. Now, the actual first layer of soil is going to be called our A horizon, or topsoil. Now, this is going to consist of small mineral particles that are mixed with organic material. And we're going to call this humus. Now, because of the relatively high organic content that was mixed in from the surface, this soil is going to be relatively dark in color. Now, most of the living organisms and nutrients are going to be found in that A horizon. As water moves down the A horizon, it'll carry some of that dissolved organic matter and minerals to the lower layers in a process that's called leaching. Because of the leaching of iron compounds, a lighter layer is going to develop below the A horizon in some cases. And we're going to call that lighter layer that forms as a result of leaching an E horizon. Now that E horizon is going to contain very few nutrients. And not all soils are going to contain an E horizon. The next major layer of soil underneath that E horizon is going to be the B horizon or subsoil. Now, while it does contain less organic material and fewer organisms than the A horizon, it's still a valuable source of nutrients for plants. Now, the area below the subsoil is going to be our C horizon, and it consists of the weathered parent material that we oftentimes call regolith. Now, this parent material contains no organic material, but it will contribute to the soil's overall chemical composition, for example, its pH. So if we have limestone as our parent material, it's going to help the soil maintain a less acidic, more basic pH. Now ultimately, the C horizon is going to rest on the bedrock, that parent material itself, which we call the R horizon. A great way to remember all of our soil layers is with a mnemonic device. One that's worked for me in the past is orange alligators eat baby carrots. So that way we remember O, A, E, B, C. Those are our major horizons. Now there's over 15,000 separate soil types that have been classified in North America alone. Now most of our cultivated land, most of the land that we use for farming, is either classified as grassland soil or forest soil. And each of those will have their own unique profiles that resulted from the complex interactions between the earth materials, the climate, and organisms. Grassland or prairie soils evolved from the nutrient-rich organic material left by decaying grass. So when we compare a desert soil profile to that of a grassland, it's going to be very different because of the plants and the animals and the parent material that was present in those particular areas. Soil is an essential, potentially renewable resource. Understanding its composition and how to conserve it is going to be essential to building a sustainable future.